All right, guys. This video is gonna be half of 2.2. So we did a little introduction to 2.2, where we looked at the empirical rule, which is the 68, 95, 99.7 rule. And then the very last question on the last page was, how do we find it if it's not going to be on 1, 2, or 3 standard deviations exactly? So that's what this video is going to look at. And so we're going to do that by hand on this video, and then in the second video we're going to do it on a calculator. So I'll show you how to do that. You're going to need a table that I posted on Canvas. It's called the standard normal table. It's also known as table A. If you see that in the book, that's what it is table A. But you're going to need that. And I'm going to show you how to use that table in this video as well. So it's kind of the plan. So this video is going to cover pages 6 and 7 of the notes. And then the next video will cover 8 and 9, and that'll be the whole unit. So according to the CDC here, the height of 12-year-old males is approximately normal with a mean of 149 or standard deviation of 9. Okay, so what percentage of 12-year-old males are less than 160 centimeters tall? So if I'm doing this problem, let me zoom in a little bit here. So if I'm doing this problem, remember we had that z-score equation. So we had z equals x, which is your individual value, right? The thing that you're looking at, minus the mean mu over standard deviation. Okay, and so we can just start plugging in some numbers here. So this equals, so our x value here is 160. That's what we care about. So 160 minus the mean, which was 149, states in the problem, divided by the standard deviation, which was 9. And type that into a calculator, and you get 1.22, right? And now this is where the empirical rule doesn't help us, right? Because the empirical rule only gave us values for 1, 2, or 3 standard deviations above and below the mean. So now we can't do it because we got some decimals. So this is where we go to the table, and let me pull up the table here. So the way this table works is, I'm going to do some highlighting. You have your z-scores here. So you have all your different z values here. Okay, and this is kind of the way it's designed is a little weird. Okay, so you have your ones place and your tenths place here, and then you have your hundreds place at the top. Okay, so you have your hundreds place at the top. So for example, this value right here represents the percentage or the probability when you have a z-score of negative 3.92. Okay, so this 0.0004 is the probability that you have a z-score of negative 3.92. Okay, so in our problem that we just did, we had a z-score of 1.22. So you just got to move around a little bit. So I'm going to see you have the negatives here, and then it kind of keeps moving on to the second page. Here's the positives. So when I'm looking at this, so I got 1.2, and then at the top you look at 0.2, so that's 1.22. That's what we're looking for. Okay, and then you just find where they meet on the table, and they meet down here. And so this right here is the probability. Okay. Now, one thing that I want to mention is that when you're looking at this like graphically, so here's your distribution, right? Here's your mean in the middle. Here's one deviation. Here's plus 1 sigma. So 1.22 is going to be right here, roughly. Okay. So this 88% is going to represent all the area to the left. Okay. So when you look at this table, it's always going to give you the area below that value. It's going to give you the percentage below. So if I wanted to find the percentage of 12-year-old males that are above 160 centimeters tall, I would have to do 1 minus this number to find this area over here in the blue, right? Which kind of makes sense graphically because that area is a lot smaller than the green area. So that's how you use this table. So let me go back to the notes. So we had z equals 1.22. Okay, and then the way we write this, you can write the probability, so P that Z, or let me actually do it this way. I can go that X is less than 160, where X is how tall you are, is equal to 0.88. 10 to 3 decimals. I guess if I'm rounding, actually, it would be 0.89 to be exact. Okay. And so now, again, this class is all about interpreting things. So what do we say? What can I write about this? I can say there is a 88.9% chance that, or let me put it this way. There's an 88.9% of all 12-year-old boys are less than 160 centimeters. Okay. Let's look at another example. So percent of 12-year-old males are greater than 145 centimeters tall. Same sort of setup, right? Z equals, and on the AP exam, they want you to write the equation too. So I posted a formula sheet on Canvas as well. You get that formula sheet on the test, but on the AP exam, they want you to write the equation and then they want you to plug everything in, right? So then you go 145 minus 149 divided by 9. And this is 4.56. Oh, sorry, wrong number. I was looking at the wrong thing on my notes. This number here is negative 0.044. Okay. So now this is your z-score, right? And again, what does this mean? We are 0.44 deviations away from the mean. That's what a z-score tells you. I'm going to write that down. The z-score tells you the number of deviations away from the mean. Keep that definition in the back of your mind. So we are 0.44 deviations below the mean. That's what this means. And so now, same thing, you go to your chart. I'll do this one again. I'll walk you through this one as well. So we go to here. Now we're going to negatives. Same thing, negative 0.4. And then we need the 4 at the top as well. So you kind of have to line these up. Let me zoom out a little bit. Right, so when you look at this, we have negative 0.4 here, 0.4 at the top. Find out where they line up, which is right here. So 0.32997. Okay. So we had a p-value . .32997. Okay. Now, the question is though, right? We're looking for the percentage of males that are going to be greater than this number, right? So again, remember on the chart, that's always going to give you the number less than. So how do I find the number greater than? I'm going to take this number, I'm going to subtract it from 1. So to find this actual probability, you go 1 minus. Find the probability that x is greater than 145, we go 1 minus 0.32997. And that equals 0.67. I rounded my answer. Okay, so then what can we say about this? We can say that 67% of 12-year-old boys are taller than 145 centimeters. Okay. Okay, looking at the next one here, same type of setup. I'm going to do this one really fast. Z equals, I'm going to type this one out, 190 minus 149 divided by 9. Okay. This equals 4.56. Okay. Looked it up on the chart. It's off the chart. So you can just say that the P value so if you look that up on the chart, you get like 0.99999, but we want the percentage that are greater. So the probability that x is greater than 190 is approximately 0. Okay. So what can we say about this? Approximately 0% of all 12-year-old males will be taller than 190 centimeters. Right? 190 centimeters is pretty tall. All right, scrolling down, looking at the next one. Here we're gonna have to do 2 different z-scores and then subtract the 2 away. All right, so here we're looking at, you wanna find the area in the middle. So what we're trying to do here, I'm just gonna draw a picture, right? So we have distribution, okay, 149 is in the middle, so 140 is below that. Here's 149, 140 somewhere over here, 160 somewhere over here, okay? And we wanna find the area in the middle. So what can we do? We can take the big area, right? So we take this red part, which is the whole thing, up to 160. Take away the green area over here, and you'll be left with the blue stuff in the middle. Okay, that's kind of the idea. So we're gonna do 2 different z-scores. So the first one, so for 140, we have z equals 140 minus 149 divided by 9 is equal to 1. The area below that, so the p-value, which is the probability, is 0.1587. Okay, now I'm going to do the same thing again, but with for 160. We do the same thing. Z equals 160 minus 149 divided by 9, which is equal to 1.22. That p-value below is 0.88888. Okay, so then to find the area in the middle, break probability, subtract the little probability. So you go 0.8888 minus 0.1587. And that's going to equal 0.7301. Okay. And if you're going to round at the very end, don't round at this point. If you're going to round at the very end, if you want to round this to 73.0, that's fine. But just keep the decimals there until you get to the end and then do the rounding. Just because you can make some mistakes when you're rounding earlier. And so now what can we say about the whole thing? We can say that 73.01% of 12-year-old boys, males, will have heights between 140 and 160 centimeters, right? So most of our boys are going to have heights in between this, right? We take a pretty large proportion of 73%. Okay. All right. Now looking at the next one. Now we're going backwards, right? So we've done this a little bit, but now we're saying what is the 85th percentile? So we want to find the percentile of heights for 12-year-old boys. So we're gonna have to go to our chart. This one's gonna get this one just takes a little bit of time to get used to, in the sense that where are our percentiles in this chart? Our percentiles are in the middle, right? Our probabilities are in the middle. So now I've got to look through all these numbers and find the one that's closest to 85%, and then look to see for the corresponding z-score. Okay. So when I'm looking at this, right, I got 0.5803 here. That's pretty close. 0.84849. This one's probably a little closer. So this right here is the 85th percentile. So what's the z-score for that? That's 1.04. Okay. So again, the middle of the chart's your percentiles, the outsides are your z-scores. So I'm going to look 1.04. So back to the notes. So now that I've found my z-score, you can write some stuff down. We go z equals x minus mean divided by standard deviation. Now I want you to think about this. What are we trying to solve for, right? We're trying to find the height. So we're trying to solve for x. So now we're just working backwards. So I've given you the z-score. We know the standard deviation. We know the mean. Now we just got to solve for x. Okay. So we found the z-score. So that's 1.04 equals the x value, which we're going to solve for, minus the mean, which is 149, divided by our standard deviation of 9. Okay. Now we just multiply by 9 on both sides. Now we change some algebra. Okay. These cross off. And I didn't do the middle step. I don't know what, let me take a look. 9 times 1.04 is 9.36. So you get 9.36 equals x minus 149. Okay. Add 149 on both sides. These cancel out. And you get x equals 158.36. 158.36 centimeters. So again, how can we turn this into a sentence? Okay. We could say to be in the 85th percentile. Let me say on the 85th percentile. A 12-year-old boy will need to have a height of 158.36 centimeters. So again, that interpretation piece is going to be really big in this class. Okay, moving on. What is the value of Q1? Okay, so again, if you can't remember, Q1 represents your first quartile, so Q1 equals 25th percentile. Okay, so I'm just kind of work this fast. The z-score, I'm not going to look this up, negative 0.67. Then you set it up, negative 0.67 equals x minus 149 divided by 9. When you solve this, you get x equals 142.97. Okay. Now, as a quick sanity check, right? If you're in the 25th percentile, you're going to be below the mean or below the median, right? And so your value here for x should be lower. Okay. If you're in the 85th percentile, you're going to be above the mean, right? So your value should be above, right? You should have a bigger number, which is what we get. And then to make a sentence out of this, to be at the 25th percentile, which is also Q1, a 12-year-old boy needs to be 142.97 centimeters tall. So again, when you take tests and stuff, I'm going to be looking for the sentence at the very end. So I'm going to look for this work, look for the setup, get an answer, and then just give me a quick interpretation of this value. Another one you could write is 25% of 12-year-old boys are going to be shorter than 142.97 centimeters. It's another way of thinking about that. Okay, moving on to the next page. In a recent tennis tournament, Rafael Nadal averaged 115 miles per hour serve. Assume the distribution of serves is approximately normal with a mean of 115 and a standard deviation of 6. Okay, what proportion of serves are expected to be lower than 103? I'm going to go through these a little faster here. So z equals 103, right? That's our x minus the average of 115 divided by the standard deviation of 6, which equals -2, right? You can either use the empirical rule because it's a whole number, or you can look it up on the chart. I just looked it up on the chart. I got p equals 0.0228. And again, make sure you read the question, right? We're looking for the value slower, so this number is good, right? If you wanted to find the proportion of serves that were faster than 103 miles per hour, we do 1 minus this. And then what can we say about it? 2.28% of Nadal's serves will be slower than 103 miles per hour. Okay, moving down. Again, make sure you're reading the question, right? What proportion or percentage of serves would you expect to exceed 120, so go faster than 120? So as soon as you say exceed, you got to go 1 minus at some point. So same sort of setup, z equals 120 minus 115 divided by 6, z equals 0.833. The p-value here is 0.7642. 1 minus 0.7642 is equal to 0.2358. So what can we say? 23.58% of Nadal's serves will be faster than 120 mph. Okay. Move on to the next one. What percentage of Nadal serves are going to be between 100 and 110? Same thing. We're looking in the middle, right? So graphically, again, if you want to see it, do this real quick. So 115 is here, right? 110 is below that, so here's 110. roughly 100 is below that. So we're trying to find this area here. Okay, so what can we do? We take the big area, which is this blue one. Okay, take all this, subtract away this pink one over here, and we're left with the area in the green. Okay, so that's the idea. So what do we have? So for 100 or for 110, Z equals 110 minus 115 divided by 6, which equals negative 0.833. The p-value is 0.2033. Okay. For our 100, we have Z equals 100 minus 115 divided by 6, gives you a Z value of negative 2.5, a p-value of 0.0062. So to find the middle, take big number minus small. So you have 0.2033 minus 0.0062 gives you a probability of 0.1971 equals. So now what can we say? Let's transfer into a sentence. There is a 19.71% chance that Nadal's serves will be between 100 and 110 miles per hour. Okay. The fastest 30% of Nadal serves go at what, at least what speed? So this is the opposite direction, right? So we're looking, we got to find the percentile on the chart and then look at the corresponding z-score and solve backwards. So, and again, be careful, right? Make sure you read the question. We're looking at the fastest 30%. So what does that mean in terms of values that are below? 70% or below, okay? So this means that we need to look at the, so fastest 30% means 70th percentile, okay? Because again, percentiles are all probability of below. So the corresponding z-score on the chart is 0.53. And when you solve this, you get 0.53 equals x minus 115 divided by 6. When you solve for x, cross multiply and then add 115, you get x equals 118.18. And so what can I say? The fastest, or put this way, for Nadal's serves to be in the fastest 30%, serve will need to go at least 118.18 miles per hour. So again, make sure you guys are reading the question as you go through these, especially on a test when you're trying to rush. Don't think this is just the 30th percentile, where you want the fastest 30%, so this is 70th percentile. So just be careful there. Let's see, next one. A different player has a standard deviation 8 on his first serves, and 20% of his serves go less than 100 miles per hour. If this distribution of his serve speeds is approximately normal, what is the average first speed? Okay, so This one, we're solving for the average, right? It's still the exact same equation. Okay, I'll walk through this one. It's a little slower. So we have the exact same equation, z equals x minus x bar divided by standard deviation. And this is why we kind of start with writing out the equation, because now we can start plugging in stuff that we know. But what do we know? We know his standard deviation is 8. So I'm going to have something over 8. It's a good start. Okay. We know that 20% of his serves go less than 100 miles an hour, right? So his 20th percentile is 100. So that 100 could represent my x minus x bar, which that's what we're trying to solve for. And now we're going to the chart to look at what the 20th percentile is. Okay. And so that, if you look that up on the chart, you get a negative 0.84. Okay, so I'll kind of talk through that again, right? So we know his 20th percentile is 100 miles an hour, right? So we know this individual value, when you subtract the mean and divide by the standard deviation, is going to give a z-score negative 0.84, because this z-score negative 0.84 corresponds to the 20th percentile. Okay, and so now that we've set it up, now we're just solving for x bar. Once you solve for x bar, you get 106.72. Okay, and so could we say something about this? We could say something along the lines of, if a player has a 20th percentile value of 100 miles per hour for his serve and a standard deviation of 8 miles per hour, then that person will have an average serve speed of 106.72 miles per hour, right? And again, you can always double check this. You could plug this back in, right? You can go 100 minus 106.72 divided by 8. That will give you this 0.84. This 0.84 then corresponds to the 20th percentile. So you can always work backwards as well to double check. Okay. Last couple of things. What is the standard normal distribution? Okay, this is the, let me write this out. A normal distribution is a special distribution. A normal distribution with a mean of 0 and standard deviation of 1. Okay. In any normal distribution, Q1 is how many standard deviations below the mean. How long is the IQR in terms of standard deviation? Okay, so the way we think about this, Q1 represents what percentile again? It's 25th. Then if I go to the chart, again, look in the middle for the 25th percentile, find the closest one, you get negative 0.67. Okay, I can do the same thing with Q3. This negative is a z-score, is a z-value. Q3, same thing, equals 75th percentile. And that's positive 0.67. Okay, and again, that represents your z-score. And again, 70th percentile, try find 75% in the middle of the chart, and then find the corresponding z-score. And so then what could you say about IQR? So what's the distance between negative 0.67 to positive 0.67? That's going to be 1.34. And again, what does a z-score represent? It's the number of deviations. So it's 1.34 deviations. So how long is the IQR in terms of standard deviations? Is 1.34 deviations. Okay. So that's the end of this video. Took a look at we took a look at a lot of different normal distributions and how to use that table. In the next video, we're going to go over how to do it with a calculator, so that'll be helpful as well. All right, let me know if you guys have questions. If not, have a great rest of your day.